Hello everyone, welcome back again to my channel. Thank you for following. So today we have a particular question before us. We're asked to solve x equals to square root of x raised to by the square root of x with the value of x ranging between 0 and infinity. Okay, to tackle this we say solution. First, we remember we can say square root of x can also be x raised to power half. If we agree on this, that means we are progressing smoothly together. If the square root of x is raised to power half, we can therefore say x equals to x raised to power half raised to power this square root of x. And also remember, in the laws of indices, we will say x is raised to power n times n. How do we tackle this? We quickly and simply write x and multiply the powers. So we'll do that here. That means s will become s raised to power 1 over 2 1 over 2 times square root of x. Yes. So if we know this 1 over 2 square root of x, all right. So if this is possible, you see that we are getting the shape already. So we take the natural log of both sides by saying log base 10 of s equals to log the base 10 of s raised to power 1 over 2 root x. Yes. And we know that when log base 10 of s is raised to power a, it means that a log to base 10 of s. We want to break that in here. You see that? So log to base 10 of s will be equal to half root s log base 10 of s. Yeah, this is fine. So we can say log to base 10 of s minus 1 over 2 s log 10 of s equals to 0. We'll only simply move all the terms to one direction, to one side. But if you look closely, we can see that log to base 10 of s is common to the two terms. So we can factor that out to mean log to base 10 of s 1. If you take this from here, to be left with 1 minus 1 over 2 log s and square root of s equals to 2. You see, now it's taking shape, it's getting better shape already. Now from here, we can either say log s to log 10 to the base to log to base 10 of s is either is equal to 0 or 1 minus 1 over 2 root of s equals to 0. These are the two possible values of s that we can derive from here. So we will deal with them case after the one case after the other, first case, second case, you know. So first of all, let me take you back a bit. Maybe you might be confused on this line, how we got this line from here. If you are confused, multiply back log base 10 of s times 1, you get this back. Log to the base 10 of s times this, you get this back, equals to 0. So it's simple, you know. Okay, so let's continue from here. Let's just say case 1. First case, log base 10 of s equals to 0. But log base 10 of s of 1 is equals to 0. Yes, this is the standard form, one of the laws of indices. So if this is correct, anywhere we have 0, why not we replace it with log 1 base 10? That is to say, log base 10 of s equals to log base 10. See? Fine. And if you can look closely, we can factor out sometimes. If you look, we have log base 10, log base 10. The only thing that differs here is the s and 1. That is to say, the s is equals to 1. That's the first answer to this one. S equals to 1. Don't forget. Here, s equals to 1. And case 2. Case 2, 1 minus 1 over 2 of s equals to 0. So how do we handle this? We can either say, let's take x, the term that contains x, to one direction, to one side, and let the constant be on its own side. So that means 1 will be equals to 1 over 2 root s. Root s, that's it. 1 over 2 root s. The minus sign has vanished. You see that? Because we move the entire term to this other side and it becomes positive. Negative sign has disappeared. Okay, now, so if we have this to be correct, what if we decide to, what are we trying to get? We're trying to get the value of s. We want everything to leave s, let s stand alone. So how can we do that? First of all, we attend to the half. What do we do to this, to both sides to eliminate half? If we multiply by 2, it will eliminate the half. That means we have to do it to both sides, both the left and the right hand side. That is to say, 1 times 1 over 1 times 2 over 1. We're bringing 2 now, equals to 1 over 2 times 2 over 1. 2, you see, times this square root of x. From here, we can conclude by saying that if you do this, you have to equal to this will cancel this to be left with root s. If it is root s, what can we go from here? So we have 2. If we decide to square both sides, like I said before, all we are doing is to ensure that s stands alone. If we decide to square both sides, it will be 2 squared equals to s squared. You see? And it says 2 squared is 4. That is 2 times 2. Remember your indices. 2 times 2. 2 multiplied itself 2 times. This is x. Inside the bracket is actually 1 over 2 times 2 over 1. That means this 2 can kill this 2. Is equal to, so s will be equal to 4. Very fine. In case 2, s equals to 4 for case 2. If that is correct, we can therefore prove if what we got is correct, we can prove it. But before we do that, if you are getting values already from these tutorials, please do well to like. Yes, hit on the like button. Share too. And if you have not subscribed, go ahead and subscribe and hit the notification bell so that anytime we publish beautiful videos like this, you'll be the first to know. Alright, let's go for the proving. And in proving this, we must use the original equation. The equation given to us was this. We want to prove if our answers are correct. The first case, in place of s, put 1. Look at s, we're replacing it with 1. Equals to root 1 raised to power root 1. You see that? Root 1 is equals to, root 1 is 1, and raised to power root 1 is 1. And 1 is therefore is equals to 1. What is inside there is equal to what is on this side. And that means our first case satisfied the equation. You see? And the second case, s is 4. Anywhere you have s, replace it with 4 also. So we're going to say 4 is equals to root 4, also raised to power root 4. That is to say, what is that number that will multiply itself to give us 4? He said, multiply itself 2 times to give us 4, square root. Okay, so we have 4, and that number is 2. 2 times 2, 4, 2 times. And this is 2. You see? And he said, 4 is equals to 2 raised to power 2 is 2 times 2. 2 times 2 is simply 4. So we have seen that the value of s we have for case 1 and case 2 satisfy the original equation. And our answer is actually correct. The first value is 1, the second value is 4. Thank you for staying to the end of the video. Like I said, if you have not subscribed, please subscribe and hit the notification bell. Also, share this video so that more people can have visibility to this video. Thank you very much. Bye-bye.